Okay, for completeness' sake, I'm going to do a second example, this time one that's a little more involved. It's going to have a special little trick to it, little thing going on. So let me put that one up here. So our second rational function to graph, a little more difficult one, going to be x squared plus 2x minus 8, all divided by x plus 1. So to do this, we're going to follow all the same steps as before. So again, they're in your notes. If not, like they're right back here, but not that there's really that much there. So I'll just talk through them and try to use the colors. So first, for our EBA, we have to do the division. So for the EBA down here, we've got to divide x squared plus 2x minus 8 by x plus 1. So when I do that, x goes into x squared x times, be x squared plus 1x. Draw the line, change the signs. It's going to leave me 1x minus 8. X goes into 1x positive 1 time. So that gives me x plus 1, and then really none of this is going to matter, basically because we only need the actual function. So though it's written kind of small, what you might notice is that now this time we don't have just a number for our EBA, we actually have a line. So one with slope, we have a line y equals x plus 1, which has a slope of 1, positive 1, and a y-intercept of 1. So we can start by kind of graphing that guy out. So our y-intercept for that EBA is going to be right there, so I'll just kind of dot it so I can see it. Then my slope is up 1 over 1, so I'm not the greatest straight line drawer in the world, but give it a shot. So there is my EBA. So again, it'll still have the same behavior as x gets really, really big, like close to infinity or negative infinity. It gets closer and closer to that line, y equals x plus 1. Okay, next for the holes, remember what we have to do is we have to actually factor this thing and figure out the new function. So on top, if I do a diamond, just because that's how I learned it, negative 8 plus 2, be positive 4 and negative 2. So it's going to factor on top to x plus 4, x minus 2, all over x plus 1. And what you might notice is that nothing actually cancels at that point. Like there's nothing that's going to make a 1. So in fact, we don't have any holes. There are no holes, or there are none. So that's nice. We don't have anything to plot though. So we have to move on to the next piece, which would be the vertical asymptote. So recall that the vertical asymptote sets the bottom equal to 0. So our denominator here is x plus 1, and when that's equal to 0, we get x equals negative 1. So we have one vertical asymptote at negative 1, so I can go and plot that right down here with a nice red vertical line that we will never ever cross because that would be bad. So there's that. So we've got kind of this like crisscrossing shape. I won't declare it some sort of animal or marsupial because people give me weird looks when I do that. Next we move on to the zeros. The zeros are going to be when the top's equal to 0, and since we already factored it, you can imagine if we set the top equal to 0, we'll have negative 4 and positive 2, and so writing those as points, we'll have negative 4, 0 and 2, 0, and so we can plot both of those guys. So negative 1, negative 2, negative 3, negative 4, 1, 2. So notice that we got a point on both sides of the vertical asymptote. That's really good. That helps us out a little bit. We won't have to necessarily find any points. And then last but not least, finding the y-intercept. We just have to plug in 0. So it doesn't really matter where I plug it in this time because nothing factored or nothing canceled. So, but I will plug it in here just for simplicity. So 0 plus 4 is going to be positive 4. 0 minus 2 is going to be negative 2. And 0 plus 1 is going to be positive 1. So this will be negative 8 over 1, which equals negative 8. So we have a y-intercept at 0, comma, negative 8. And once again, we can plot that down here. Negative 1, 2, 3, 4, 6, 7, 8. And so there we go. We've got all our piece of information down. We have a point on each side of the vertical, or on the, yes, each side of the vertical asymptote. So now we just have to hug our asymptotes. So again, realizing that as we get big, it's going to get closer there. We're going to kind of get a pattern like that. So again, it's not totally precise, but it's pretty good. There's my left side. Again, I hug the asymptotes in both cases, getting up to the vertical asymptote, and hugging the EBA as we imagine it approaching negative infinity. On this side, we do the same thing. So not my best work, I don't think, but fairly decent. And there we go. There is our function. So you might notice that it passes the vertical line test at all points, so it's definitely a function, and yeah, it just looks pretty cool. So there we go. There would be a second example of graphing a rational function, this time having a slant asymptote. Hopefully this has been informative and helpful, and that you'll do better and your homework won't look so awful and your test won't be awful. So thanks, have a good night, bye.